Okay, so when we look at 6.2, it says solving quadratic equations by graphing. So we spent that whole time on 6.1 graphing them, and now we're going to solve them. So a quadratic equation is an equation in the form of ax squared plus bx plus c equals 0. This whole chapter 6 is all about parabolas. Everything you graph, everything you look at will be a parabola. It'll be x squared. The solutions of a quadratic equation are called roots. Finding the zeros of the quadratic is one method of finding the roots. All right, so solutions, roots, zeros, those things all mean the same thing. A quadratic equation can have one real solution, two real solutions, or no real solutions. So we're looking for either one solution, two solutions, or none. If we're going to solve them by graphing, where the graph crosses the x-axis, or where the y values are 0, and that's why we say finding the zeros, are the solutions. Okay, so number 1 there says solve negative x squared equals 4x, solve it by graphing. Alright, first of all, if we're going to put this guy into our calculator, because we have him, we might as well use him, we need everything on one side of the equal sign. So I'm just going to subtract the 4x. So I have negative x squared minus 4x equals 0. So in my calculator, I'm now going to put negative x squared plus 4x into my calculator. Okay, so I'm going to go to y equals. Clear out anything that you have in there.
Hey, why did it minus 4x plus 4x?
They're on different sides of the equal sign. Oh, that right there?
Yeah.
He didn't. I just was going too fast. Thanks, Thomas. There, that looks better, right? When you put it in your calculator, make sure you're using the negative sign and not the subtraction sign out front. So negative x squared. Hi. How are ya? So I might be able to, just not all of it. Does that make sense?
Yeah.
Okay. Okay, so did you see something like that in your calculator? We now should open up down because our coefficient of our square term is negative. And now I'm going to go look at my table. So if I go look at my table, I should see some really interesting things. All right, let's graph him first. At negative 4, 1, 2, 3, 4, I'm at 0. Negative 5, I'm at negative 5. Negative 3, I'm at positive 3. Negative 2, I'm at 4. Negative 1, I'm at 3. 0, I'm at 0. And positive 1, I'm at negative 5. Now, it says we're looking for the zeros. We're looking for the points when our y values are 0. When my y value is 0, I'm crossing the x-axis. Well, if I look at my table, that happens there at -4, but it also happens there at 0. See that? So they're calling it the zeros because I'm looking for when my y value is 0. That's the x-intercept. So my solutions are x equals 0 and x equals -4. What? That's it. Okay, let's see if it works. If I plug 0 in to this guy right here, I have -0 squared. Well, that would be 0. Does that equal 4 times 0? Yeah, it certainly does. How about -4? Okay, so -4 would be +16. The negative out front would make it -16, and 4 times a -4 is -16. Okay? So we're finding the values that make this equation true by graphing this guy. Okay, so at the beginning I moved the 4x to the left, right? And I subtracted him. What if I would have moved the x squared to the other side? Would that change where he crosses my x-axis? I don't know, let's see. What an, I got to erase my screen. If I would have moved him to the other side, I would have had 0 equals x squared plus 4x. Okay, so let's plug that in, and I'm going to do it on a different one so you can see it. So there's our original one. There's if he would have opened up. Did it change? He just flipped over, right? Did he cross his x-axis at a different spot? No. I still have a 0 at -4 and a 0 at 0. Does that make sense? Okay, let's try another one. Look at number 2. I can't put the equal sign in my calculator, so what do I need to do? Add 4. Okay, so in my calculator, I'm going to put y equals x squared minus 4x plus 4. Rid of the old stuff. X squared minus 4x plus 4. He should look like that. Let's go look at our table so we can accurately put him on our paper. So second graph. So 0, I'm at 4. 1, 2, 3, 4. Positive 1, I'm at 1. 2, I'm at 0. 3, I'm at 1. 4, I'm at 4. What's going on with that guy? What do you think? The vertex is sitting on the x-axis, right? So here at the top I said you could have one solution, two solutions, or no solutions. Okay, so this first guy had two solutions, right? He crossed him in two places. This guy only has one solution because my vertex is sitting on my x-axis. So what's my only solution here? X equals 2. Okay, so we had him cross twice. We had the vertex sitting on the x-axis. What do you think's gonna happen when I get no real root? Any ideas what a graph like that might look like? If we're looking for him to cross the x-axis. Right, he doesn't cross the x-axis at all. So if I have a graph like this, and he opens up, does that guy touch my x-axis? No, he doesn't have any real roots. How about one of these? Whoops, sorry. Does that guy have real roots? No. So anytime you have a graph where the verts or anything doesn't touch the x-axis, we have no real roots. So it can open up and it's above the x-axis. It can open down and it's below the x-axis. Okay? All right, those are your 3 possible scenarios, or 4 I should say. It touches it twice. It touches it once because the vertex is sitting on it. It doesn't touch it at all. Okay. Let's skip to number 4. You try it. Put it in your calculator. Put it on your paper. Tell me where it crosses the x-axis. Oh, sorry, he goes off. That's okay, though. We're just looking to see where he crosses. So did you get he crossed at -1 and +4? If you didn't, stop me and I will help you. Alright, now, those ones worked out really nicely and they crossed at nice pretty numbers, but will they always cross at nice pretty numbers? No, they won't. So that's why I want to show you number 3. So this guy, everything, we got x squared minus 6x plus 3, and it says solve by graphing it. Okay, I'm going to put that guy in my calculator. X squared minus 6x plus 3. And then I'm going to hit graph so I can see what he looks like. My x squared is positive, so he'll open up. But if you look at him, wait for it. See how he doesn't cross at nice, pretty numbers? In fact, when I go look at my table, we were looking for zeros in the y values. Is there zeros in the y values? No, there's not. Okay, well, let's graph the ones that we can see. All right, at 0, I'm at 3. At 1, I'm at negative 2. 2, I'm at negative 5. Well, this one goes off too. 3, I'm at negative 6. 4, I'm at negative 5. 5, I'm at negative 2. 6, I need to fix that graph. So we know from looking at our picture that somewhere between 0 and 1, I have a root. So somewhere between x equals 0 and x equals 1, there's a root. And somewhere between x equals 5 and x equals 6, there's a root. And I can also see that because I notice there's a sign change in my y values. If you look at 0, I'm positive 3. And then you look at 1, I'm at negative 2. Somewhere in between there, it's got to be 0. To go from a positive number to a negative number, it's got to be 0 somewhere in between there. Same thing with 5 and 6. I go from a negative 2 to a positive 3. So somewhere in between there, it's got to be 0 as well. The cool thing about your calculator is it can find it for you exactly. Okay, so let's make it work for us. So, just like when we were finding the vertex, we're going to go to that calculate menu. Right there, it says calc. So I'm going to do second trace. Just when like we were finding the vertex, we were having to pick maximum or minimum. Look at number 2. It says find the 0. That's what we want. So we're going to go to number 2. And there's my blinky spider again. And remember, he moves around. When I arrow to the left and to the right, my spider moves. Okay. It asks you some questions, just like the questions it was asking you to find the maximum and the minimum. So it says the left bound. First question it's asking is the left bound. Are you on the left side of my 0? Okay, I'm going to tell it, your calculator, look somewhere in between, let's see if I can do it. Somewhere in between here and here. Somewhere between those two values, I have a 0 value. Okay, so this guy's opening up. I want my spider above it. And then it asks me the right bound, and I'm going to say to the right-hand side of it. So I need to be below. So, see how I put 2 little dotted lines in there? I'm saying somewhere in between there, it crosses my x-axis. And then the calculator says, do you want me to guess? Yes, please. Now, as you'll notice, the y value should have gone to 0. Or you should have gotten scientific notation. It should say like e to the negative, I don't know, whatever, 12. This guy right here to 2 decimal places is where he actually crosses. So 0.55. Which is good because we said it was somewhere between 0 and 1. All right, so my spider. This guy opened up. I put my left bound above, my right bound below, because I want to look in between them. Alright, now I need to find this guy over here. Okay, so I'm going to do it again. Second, trace a 0. Arrow over somewhere, so I'm to the left side of my 0, looking across my x's. So this time, I want my left bound to be below. And then it says right bound. Okay, you have to cross over. Oops, sorry. And I'm going to say somewhere in between those two vertical lines, it crosses the x-axis. So my right bound has to be above. And yes, please, calculator, guess for me. So to 2 decimal places, this guy also crosses at x equals 5.45. Which is good because we knew it was somewhere between 5 and 6. Okay. I have one more thing to show you. On Canvas, there is a sheet that's called 6-2 calculator moves. It shows you what to push, but the most important part are these two pictures down here at the bottom. So if you want to copy those down into your notes, if he's opening up, left bound on one that opens like this, right bound, left bound, right bound. If he opens down, left bound, right bound, left bound, right bound. Half of the ones on your worksheet don't cross at nice pretty numbers. The other half do. There you go. I just did it in 6. We went back to a 10 by 10. Okay, so let's look at your worksheet. So turn the page a couple pages till you get to your worksheet. This one I had to make. You don't have to show me your table on your paper unless you're doing it by hand, but I would suggest you just grab a calculator and plug it into your calculator. Okay? So it looks like this guy right here. There's 4 on the front. Of those 4, 2 of them will not cross at nice pretty numbers. Then turn the page, there's 4 on the back. The form just changed a little bit, so I just wanted you to get used to seeing them in different ways. We call this vertex form, and we'll talk about how to put it in there later. This guy in the back is more of a standard form. And again, 2 of those on the back side will not cross at nice pretty numbers. Okay? Questions on that? Yeah, Jaden.
Are you going to show us how to do the first form before we do our homework?
Do you want me to show you how to just plug it in your calculator? Is that what you're saying?
Is it like different to plug it in?
No.
You just type it in.
Just type it in how you see it. Yeah, we can do one together. So let's do number 1. You just have to use your parentheses. So you're just going to do x, parentheses x, plus 4, close your parentheses, square it, minus 1. Now you're using your calculator, so you should be able to accurately put your graph from your calculator onto your paper. So he should look like that. Second graph, so at negative 6 I'm at 3. Negative 5 I'm at 0, there's the first one. Negative 4 I'm at negative 1. Negative 3 I'm at 0, there's the second one. Negative 2 I'm at 3. Would you like to take like 10 minutes and just work on this? Yeah? Okay, let's do that.